In Amazon Elastic Container Service, or ECS, a cluster serves as the fundamental organizational unit for your containerized applications. It's a logical grouping that helps you manage your compute capacity, whether it's composed of Amazon EC2 instances that you control or the AWS managed infrastructure of AWS Fargate. So understanding ECS clusters is key to effectively deploying and scaling your container workloads. An ECS cluster acts as a regional construct that provides the compute capacity for your containerized applications. It doesn't represent a single machine, but rather an abstraction that pools resources where your tasks, the running containers, or container instances reside. When using the EC2 launch type, an ECS cluster is comprised of Amazon EC2 instances that you provision and manage. And these instances are installed with the ECS agent, which allow them to register with the cluster and run container tasks. With the Fargate launch type, the cluster is purely a logical grouping. You don't manage any EC2 instances. AWS Fargate fully manages the underlying compute infrastructure. But regardless of the launch type, every ECS task and service that you define must belong to an ECS cluster. The cluster serves as the environment where your containerized applications are deployed, scheduled, and run, providing the necessary resources and organizational boundary. So how do we create a cluster? Well, to begin creating an ECS cluster, you first navigate to the Amazon ECS service in the AWS Management Console and select the Clusters section. During the cluster creation wizard, you'll be prompted to choose your desired cluster template or launch type, either EC2 or Fargate for serverless compute. And if you select the EC2 launch type, the wizard will guide you through configuring your EC2 instances. And this includes selecting the EC2 instance type, like T3.medium for example, and specifying the desired number of instances and defining the virtual private cloud or VPC subnets and security groups where these instances will be launched. For EC2 clusters, the creation wizard can automatically set up an auto-scaling group, and the ASG ensures that your desired number of EC2 instances are maintained and can automatically scale the number of instances up or down based on predefined policies. And when choosing the Fargate launch type, the process is significantly simpler regarding compute management. You don't select instance types or quantities, you only need to define the networking settings, the VPC and subnets, where your Fargate tasks will run. And after configuring the necessary details, you finish the creation process, and AWS then provisions the resources, and then you wait for the cluster status to change to active, indicating that it's ready to accept tasks. Now, the ECS console provides a dashboard for each cluster, allowing you to monitor its health, view the number of running tasks and services, and examine resource utilization metrics for the cluster, like available CPU and memory. And if you're using the EC2 launch type, scaling and managing the underlying compute capacity involves adjusting the auto-scaling group associated with your cluster. And this includes changing desired capacity, min-max instances, or scaling policies. With Fargate, you don't directly scale the cluster itself in terms of instances. Instead, the scaling of your application is managed at the service level, where ECS automatically launches or stops Fargate tasks as needed to meet demand. And for EC2 launch type clusters, if you want to update the operating system, Docker version, or ECS agent on your container instances, then you would perform a rolling update of the underlying EC2 instances to replace them, with the instances running the new AMI. And the choice between EC2 and Fargate clusters often depends on your specific needs. Fargate offers simplicity for ephemeral microservices and event-driven architectures where you don't need to manage servers. EC2 clusters provide greater flexibility for custom operating system configurations, specialized instance types, or when you need deeper control over the compute environment. Now, in the EC2 launch type, each EC2 instance that is part of your ECS cluster runs an ECS agent. This agent is a specialized Docker container that enables the EC2 instance to communicate with the ECS control plane, register its resources, and run tasks assigned to it. With the EC2 launch type, you explicitly see and manage the EC2 instances. You have the flexibility to pack multiple ECS tasks into a single EC2 instance, potentially optimizing resource utilization and cost if you manage the packing efficiently. And the responsibility for patching the operating system, updating Docker, managing security patches, and scaling the EC2 instances falls on you. Meanwhile, with Fargate abstracts away the underlying infrastructure completely. You provide your task definitions, and Fargate handles the server provisioning, scaling, and management for you. With Fargate, your focus is entirely on defining the resource requirements like CPU and memory for your individual tasks. And AWS automatically provisions the exact amount of compute capacity needed for your tasks to run efficiently without you ever having to interact with or manage a server. Now let's talk about networking and security. Now, ECS clusters and the tasks within them always run within an Amazon Virtual Private Cloud, or VPC. This provides a logically isolated network where you can control your IP address ranges, subnets, route tables, and network gateways. Tasks communicate with each other and other AWS services within this secure network environment. And AWS IAM plays a critical role in ECS security. You can define IAM roles for your ECS tasks to grant them specific permissions to access other AWS services like DynamoDB, S3, and RDS. You also use IAM roles for the EC2 container instance if using the EC2 launch type. And ECS integrates with Amazon CloudWatch logs for centralized logging. You can configure your task definitions to send container logs directly to CloudWatch logs, providing a unified location for monitoring, troubleshooting, and auditing your containerized applications. And finally, let's go over a few observations for containerized apps. Now, ECS is ideal for decomposing applications into microservices. Each microservice can be defined as an ECS service, potentially running multiple tasks, and these services can be deployed within a single ECS cluster or across multiple clusters for architectural separation. And to use the benefits of containers, it's a best practice to keep ECS tasks stateless. Persistent data should be externalized to manage AWS databases like Amazon RDS, DynamoDB, or S3, or even caching services like Elasticache. For web applications, or APIs, ECS services are commonly placed behind an application load balancer, or ALB. The ALB distributes incoming traffic across the healthy tasks in your service. And lastly, a common CI/CD pipeline pattern for ECS involves AWS code pipeline orchestrating the workflow, AWS code build building Docker container images, and then storing these images in Amazon ECR, and then AWS code deploy automatically deploying new service updates to your ECS clusters.